This video, we're going to look at an example of finding the average value of a function on an interval. So we're given the function g of t equals t over the root of 3 plus t squared. We want its average value on the interval from 1 to 3. First thing we should do is make sure that we can actually integrate this function on that interval, which we can. This function is an algebraic function, if you will. We've got t divided by a radical function, 3 plus t squared. So the only thing I have to really worry about is making sure that I don't put a 0 in the denominator and I don't put any negatives in the under the square root as the radicand. On the interval 1 to 3, I don't have any issues with that at all. So I don't have any problems with calculating the average value of the function because it's continuous on that entire interval. Our formula for our average value of a function is 1 over the length of the interval times the integral of the function over that interval. So just plugging everything into our formula, a is 1, b is 3, so we get 1/2 integral from 1 to 3 of our function. This is when we're going to see that we need to use a u substitution. We let u equal the denominator, what's under the radical in the denominator, well, 3 plus t squared. Then in the denominator we get when we differentiate we get 2t dt. We have a t dt, so we'll have to adjust for that too, so that we can make our substitution for the du. When we adjust for the 2 on the t, we need to put a 1/2 out in front, in addition to the 1/2 we already had out in front. After making our substitution here, the 3 plus t squared just becomes the u, so we get u to the negative 1/2. The 2t dt becomes our du. We also need to make sure that we change our limits of integration. 1 and 3 refer to t values. We are now integrating with respect to u. It would be incorrect just to write 1 and 3 here for our limits of integration, because those are t's, not u's. But luckily for us, that it's not too hard to change the limits of integration. We just need to plug in our values for t and get the values out for u. Plug in 1 for t, we get u as 4. Plug in 3 for t, we get u as 12. So we have limits of integration of 4 and 12 in this case. Antiderivative for u to the negative 1/2 using our power rule. Well, we would add 1 to our exponent, gives us a positive 1/2. Divide by that new exponent, gives us a 2 out in front. Use our fundamental theorem of calculus now, plug in your endpoints and simplify, and you should get root 3 minus 1 for the average value of the function.